Every winter, pine trees glow in living rooms, but deep in the forest, they also drip a golden resource worth a fortune. After years of slow growth, workers open a precise channel in the bark, and resin begins to flow like warm honey down the trunk. Minutes later, that sticky liquid is rushed toward a modern distillation line, where heat and steel turn it into turpentine and amber rosin for countless materials. At the same time, mature cones dry and crack open, releasing pine nuts, small seeds packed with rich oil and surprising value. Some cones are gathered by hand from the forest floor. Others are shaken from plantation canopies in a harvest that lasts only days. Today we follow the pine's full journey, from careful tapping and cone collection to the factory where every second protects quality. If you love real farm-to-factory stories, follow Agriculture Insight. And let's step inside the massive modern world of pine. Before we step into the factory, we have to understand why pine is not just a seasonal decoration. It is a working tree that supports entire rural economies. The pine family spans well over 100 species, yet only a smaller set is commonly used at industrial scale because not every pine yields resin, cones, or timber in consistent commercial volumes. In practice, the pine world is divided into three visible paths: resin-focused stands that feed chemical materials, nut-producing pines that deliver oily kernels, and Christmas pines grown mainly for holiday markets. What makes pine special is that its value is tied to survival, because resin is the tree's natural shield against injury, insects, and infection. When the outer bark is opened, the tree pushes resin outward under internal pressure, sealing the wound while keeping the wood core strong. This same resilience shows up in the way many pine ecosystems respond to wildfire, because heat can trigger cones to open and scatter seeds onto clean mineral soil. In parts of North America, forestry managers use controlled burns to reduce fuel buildup and support healthier regeneration cycles, turning fire from a disaster into a managed tool. Time is another force. Pine seems to outlast. And in the high, cold, white mountains of California, ancient bristlecone pines have endured on rocky slopes for thousands of years. These extremes help explain why pine plantations are often built with long-term planning, where today's planting decisions shape harvests a decade or more into the future. For Christmas tree farmers, the work looks calm on the surface, but the schedule is strict because the market demands symmetry, density, and a clean taper from base to tip. Over years, growers prune and shear trees again and again, guiding branches into a balanced cone that will hold ornaments without gaps. Only when a tree reaches the target height and fullness, often after many seasons of shaping, does it qualify for harvest. During cutting, crews keep the saw low and steady, because snapping a limb or scuffing the crown can instantly drop the tree into a lower grade. Once felled, trees are gathered in bundles, moved by hand, small trailers or field conveyors, and in some large operations, lifted out quickly to reduce ground damage. At the staging area, net wrapping machines compress the branches into a tight silhouette, protecting the shape and reducing needle loss during transport. Cardboard cartons and labeling finish the job, turning a living tree into a carefully handled product that must arrive fresh, straight, and intact. And while these holiday trees rarely enter heavy industrial supply chains, they share the same origin story as resin and pine nuts: patient growth followed by precise, timed harvest. With that foundation set, we can now follow the other two high-value paths: the resin that becomes modern chemistry, and the cones that hide liquid gold inside their kernels. Out in the resin plantations, the main character is the pine trunk itself, standing in rows like a living pipeline that can produce year after year. The season starts when workers scrape away a thin layer of outer bark, creating a clean, working face that keeps the next cut stable and predictable. Using a specialized resin axe, they open a slanted channel only a few millimeters deep, just enough to reach the resin-conducting layer without weakening the wood core. Instantly, the pine reacts, pushing milky resin outward as a defense, and gravity guides that sticky flow down the grain. A small horizontal lip is formed to hold a metal spout, so the resin follows one controlled path instead of spreading across rough bark. In the early days of a new tap, resin often drips into open cups, so crews can watch the flow rate and keep dirt, rain, and bark fragments to a minimum. Once the flow becomes steady, collection bags are pressed close to the trunk, reducing air exposure, slowing oxidation, and protecting color and scent. Every few days, the cut face is refreshed with a careful pass, maintaining pressure while avoiding stress that would exhaust the tree. A single pine may yield only a few kilograms of resin in a year, but the real power is time, because the same tree can be tapped across many seasons. When resin arrives at the processing facility, speed matters, because delays can darken the batch and lower the value of what the pine just produced. Large loads are warmed in heated tanks until the resin softens and turns into a uniform liquid, ready to move through pipes like syrup. Then the liquid enters tall distillation towers, where controlled heat lifts the lighter fraction first, and that vapor is condensed into turpentine. What remains is a thicker, resin-acid-rich phase that becomes gum rosin, the amber backbone used in adhesives, inks, coatings, rubber, and many engineered materials. After separation, molten rosin is spread thin and cooled slowly with water or forced air, because stable cooling protects clarity and reduces cracking. Once solid, the rosin is cut into dense blocks, stacked like golden bricks, and each batch is inspected under bright light for color and cleanliness. Clearer, lighter grades are directed toward products that demand purity and consistent performance, while darker grades go to heavy-duty industrial uses where strength matters most. Even the scent tells the story, because the sharp, fresh notes of turpentine and the warm, piney resin aroma linger in the air around the line. And with resin transformed into modern chemistry, we can follow the pine's second treasure, the cones and kernels that must be handled just as quickly to protect their oil. Pine nuts begin far from the factory, in forests and plantations where mature cones have spent months hardening and filling with oil-rich seeds. In wild stands, many harvesters still work by hand, walking slowly through the trees to gather cones that have dried, fallen, and stayed intact without mold or insect damage. For cones that remain high in the canopy, skilled workers climb or use simple tools to twist them free, taking care not to injure branches that must produce again next season. Yields in natural forests can be modest and unpredictable, because harsh weather can reduce cone set, and every kilogram of kernels represents a huge amount of patient growth. In cultivated plantations, mechanization changes everything, because trunk shakers clamp onto the lignified stem and send calibrated vibrations through the crown. When cones have reached true maturity, they drop in a sudden rain, letting an entire block be harvested in days instead of weeks. Where trees are younger or seed quality must be protected, crews use lift platforms to reach the upper canopy, while ground teams use long poles to dislodge selected cone clusters. No matter the method, the goal is the same: get cones to processing quickly, because heat and time can dull kernel flavor and reduce oil quality. Inside the plant, whole cones enter a multi-stage separation system, where pressure, impact, and friction are tuned to crack woody structures without crushing the kernels. Husk fragments and fibrous scales are stripped away continuously, while raw seeds fall onto conveyors and move toward cleaning. Vibrating sieves keep the seeds in motion, and controlled airflow lifts away lighter debris like dust, shell flakes, wood fibers, and hollow seeds that cannot meet grade. Next comes dehulling, where low-friction machines remove the hard shell with careful alignment, because even small fractures in the kernel can expose oil to oxidation. At sorting, only seeds that meet size and hardness standards continue forward, while off-grade material is removed to protect the premium oil line. The best kernels are cold-pressed in small batches, kept below low temperatures so the fatty acids stay stable, and the aroma remains clean and sweet. Pale gold oil flows from the press, then moves through fine filtration and is bottled immediately in glass, to reduce light and oxygen exposure. The remaining press cake is collected as a dense, fragrant byproduct, often used in specialty foods or further processing instead of being wasted. From forest floor cones to sealed bottles, the chain depends on gentle handling and fast timing, because pine nut oil is valuable, precisely because it is delicate. And when you connect this oil line to the resin towers, you see the full picture. One tree feeding two high-value industries through careful harvest and modern precision. From the outside, a pine tree looks simple, but inside its bark and cones are two premium resources moving through a highly disciplined supply chain. Resin tapping turns the tree's natural defense into turpentine and gum rosin, feeding materials that touch everyday products from adhesives to coatings. Cone harvesting unlocks pine nuts and cold-pressed oil, where careful cracking, cleaning, and low-temperature pressing protect a value that can disappear in minutes. Alongside these industries, Christmas tree farms show another kind of precision, years of shaping and a harvest that must protect every branch. Together, these paths prove that pine is not just holiday symbolism, It is modern agriculture, forestry, and manufacturing working as one system. The next time you smell pine, remember the workers in the forest and the machines in the plant that make those golden drops and pale oil possible. If you want more real farm-to-factory journeys like this, follow Agriculture Insight and tell us which crop or livestock system you want to enter next.